Ramen some.
Don't get on the nerves.
Ramen some.
Find underneath those curves.
Ramen some.
It isn't very typical,
Ramen some.
but you gotta find the integral. Sine 3x minus square root x. How you find that? It's not complex. Right. Middle. Left. You choose the best. Now we slice, 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 slice. Left. Middle. Right. We get in the area tonight. Now we slice, 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 slice.
Yeah. Try to find the area under this curve. The only thing that I know how to do is serve. R-I-E-M-A-N-N. Put the rectangles down to do it again. Then you gotta find the area of each. Everyone sit down cause Rich is gonna teach. Lights, cameras, action, set. Boy, for thoughts and goddammit.
What up guys, it's rapper Rich. You may know me from the music video that just happened like a minute ago. But today we're gonna actually solve, this is my little vlog showing you guys how to solve Reimann sum or finding the area under the curve for sine 3x minus square root of x. So first we're gonna go up to 2 and we're gonna be using intervals of 0.5. So we have 4 intervals. So here's how the function looks like when it's graphed, also here on Desmos. So it's very negative, as you can see. Of using Reimann sums is to find the input of 0.5 to this function, and then we'll be multiplying it by 0.5 because that's our interval length or width in this scenario. So 0.5 is our first interval. And then we're going to go to 1, and since this is negative, it'll go down here. So you're just trying to connect the rectangles to the line based on what Reimann sum you use. So since we're using right, it's on this side. So this is the 0.5 integral, and then the width for all of these are 0.5. And then now we're going to use 1, and that was 1, and then now we're going to use 1.5 for our next length. And then don't forget the 0.5. And then for the 2, it will look like this. And then the width is also 0.5. So now we're just trying to find the lengths for all of these so we can find the area of each rectangle. So to find the length for all of these rectangles, we'll be inputting the function or our x, which in this, our first rectangle is 0.5. So it'll be sine 3 times 0.5 minus the square root of 0.5. And then you do it for all of these. So since we have 4 intervals, we'll have 4 different functions or 4 different lengths that we'll be adding together. So here we inputted all of the 0.5s into where all the x's are. And you just plug this into a calculator, and then this should tell us our length. So for our first length, it is 0.29, rounded of course. And then don't forget you have to multiply it by 0.5. So then this is our first rectangle, and we have 3 more to go. So it is the same process. You just continue inputting. So for this rectangle, you would input 1. For this rectangle, you'd put 1.5. And for this rectangle, you'd put a 2. So I'm going to flash forward when I do all the boring stuff and solve everything. And then I'll show you the adding process, adding and multiplying process. So here's how a Reimann sum equation will look. So this is the length for the first box, length for the second box, third box, and fourth box. And then for all of them, we'll be multiplying it by the interval that we're using, which is 0.5. So then the answer to this should equal an approximation of what is under the curve. 1. So guys, here is our answer, which is negative 2.295, which is really close to what our the antiderivative tells us, which is around negative 2.2.